Hey folks, so this is my first stream. I've never done this before, so bear with me. But I'm just gonna be practicing some React here. I don't even really have anything planned. But the interesting thing is, I wanted to let you guys know that I got monetized this week. So what that means is, I got 1,000 subscribers, and uh, between the subscribers and random visitors, I got like 4,000 watch hours in the last year. And you might have noticed that ads started popping up on my videos, but so I turned on monetization, and I'll tell you why I did that. Uh, I turned on monetization just because I wanted to be able to earn an couple extra dollars, maybe to help my mom, help my family, and do some things like that. But I definitely want to try to make things as easy to use, or I definitely want to make it as non-invasive as possible. So just give me some feedback. If I'm showing too many ads, or if they're interrupting you too much, let me know. But anyway, so I'm just gonna kind of get started. I'm on my desktop right now. So let's see. So I'm just going to make a directory, React practice, cool, cd React practice. All right, and I'm using git bash. I'm on a Windows computer. I know I've been on a Mac previously, but my Windows desktop is much more powerful than my Mac desktop, so I'm using that to stream. So yeah, let's see. Okay, so I'm in React practice. I'm going to open up Visual Studio Code. So I'm just going to say code dot. Here we go. And then I'm also going to say npm init, like that. React practice. Awesome. Okay, just select all the defaults. And okay, so now what I want to do is I'm going to say npx create React app, like that. Cool. Oh, I have to throw a name. React practice. All right, it's going to take some time, but yeah. So let's just wait for this to finish up. But let's see. Okay. All right. It's taking a little while, and it's slowing things down a bit, but whenever it decides to finish installing. Let's see, can I make this bigger? Yeah, cool, awesome. Just installing right. Taking a minute. Let's see. So I was going to do some React, but turns out that my computer is kind of slow when it comes to downloading and installing things. So instead, I think what we're going to do is we'll just do some LeetCode problems, if that's okay. Let's see. I don't know. Let's see. Hopefully it is working. I'm just going to edit the title. Let's see. LeetCode. Let's do some LeetCoding instead. Let's see. I think I have to restart my stream, so let me restart and see what happens. Oh, maybe not. Okay. So I think my stream is catching up a little bit, but all right, so let's go to leetcode.com. All right, sign in. Actually, I'm just going to instead end. No, okay. So let's sign in with my, I think with my Gmail. All right, cool. Did I have dark mode for this? Let me just make this a little bit bigger. All right. I haven't solved LeetCode problems in a while, so let's pick a topic. Let's just get our feet wet and do some easy ones. Palindrome number, valid parentheses. All right. What language do I want to do? Java, Ruby, Typescript. Let's just do Java. And first of all, let me fix this font size, make it a little bigger so I'm not going blind. GitHub maybe? I don't know. Vim bindings, tabs, spaces. All right. All right. Oops. And cancel. Settings, theme. Blackboard? No, I don't want Blackboard. Solarize dark. Let's try that. Okay. All right. So is valid parentheses. Let's look at this. The way this works is you do like a quick string match. So you do, let's say stack is equal to new stack. Oh, but you have to tell it what it is. So stack of character. Stack is equal to new stack of character. Like that. And so valid parentheses. So we only want to check for open curly braces, parentheses, or square brackets. So we want to say for ints I is equal to 0, I is less than s dot length, I plus plus, like that, and whoops. And inside of that, we want to say if s dot char at I is equal to. All right, you know what? I'm just going to write a helper function. So Boolean check for open is open. So character C, return C equals this, oops, or C equals this, and then or C is equal to square bracket like that. All right. If is open s.char at I. So if it's open, then we want to push it on the stack. Stack.push s.char at I. Oops. Otherwise, we want to check and see if the stack is empty. So if the stack is empty, then we say return false, and then else we have to do a match. So we say we have to peek the stack. So if so basically the next we know that all the characters in the stack are open or one of these, right? So then we need to say if the stack is not empty, we want to peek the first value. So we're going to say character top is equal to stack.peek. I think that's the method, and then we need to match them. So we can say something like public match open character C and how do we want to do this? So we can basically say if C is equal to open parentheses, then if C is equal to this, C and then character D, let's call it D, and D is equal to a close parenthesis, and then this needs to be Boolean. So if they match, and then return true. I mean, I can put this all in one line. Let's do this just to show what that looks like. So we can say return if that is that, or I can just copy this. Oops. Alright, okay. And I want to do next in square bracket and closed, or and paste again, and then curly brace like this. I don't know. I feel like this is pretty ugly. But anyway, so we're going to say the top, and if it's not an open, then we need to say if not match open. So top is going to be the open character, and then it's going to be s.char at I, like this. And we return false. Right? Otherwise, if it is a match, then we stack.pop. And then at the end of this for loop, we say return stack.is empty. If it's empty, then we know it's true. Let's try running it. I feel like there's a bug in this somewhere. Yeah. What is this? Expected semicolon. All right, let's run it against another test case. Save this. Code. Ooh, it's false. All right, so why is that? All right, so let's run through this. So first one is index 0. We push the open parenthesis, and then we get the next iteration. We pop. If the stack isn't empty, okay, should match, right? Okay, so they match, and we pop it, so the stack is empty, right? Then we go again, and we match. So let's see. Can you do breakpoints in this? Nope. Okay. So let's see. Let's help ourselves out. Stack like that, and run code. Wait, what? So, oh, the square brackets aren't related to this. So let's see. So it pushes one of these, and then it pushes and so then we pop it, and then we should push the curly brace. Right, let's print the stack here. System. Okay, so it's empty. Push it on, and all right. So it's ending early, but why? Did I do something wrong here? Oh, I skipped I skipped square brackets like this. Now it should work. There we go. All right, and let me remove the system.out line, and it should work again. And let's see. Nice. Okay. Let's do another one. Problems. Let's do tags. I love linked list problems, but maybe heap, backtracking, dynamic programming, tree. Let's do BFS. All right, symmetric tree. All right, so given a binary tree, check whether it is a mirror of itself, i.e. symmetric around its center. All right, let's see what that looks like. All right, so symmetric around its center means that the left and the right subtree have to match. So so if I do a breadth first search, well, I know this problem has to do with breadth first search, so why? So interesting. So we on queue the root, and then we get its children, and we say if left is equal to right, then we continue, but we have to go from outside to inside. So all right, let's see. So how would I do this? So BFS, you have to use a queue, right? So we say queue, and it's going to be tree node. Q is equal to new linked list of tree node, like that. All right, and let's think about this some more. So what happens if the root is null? I feel like if root is equal to null, if root is equal to null, maybe we return true. That's my guess. This is something you would ask in an interview, like, do you return true if no? All right. Now, so we say q.insert root, and then while q not q dot is empty, then we do this. So we say tree node is equal parent is equal to q dot pull, like that, and then for each parent we have to basically do a level traversal of all the children, right? So right, so I think we have to keep track of like the current children size, maybe. So let's take a list of tree node children is equal to new array list or something like that, and you can say if parent dot left not equal to null. If parent dot left is not equal to null, then children dot insert oh, I know. So int current level size is equal to 1, right? And then, so basically you do for int I is equal to 0, I is less than current level size, I plus plus, and then you do this. And I think that's right. And then we insert parent dot left, and then if parent dot right is not equal to null, then we say children dot insert parent dot right. I think, right? So what this will do is we will insert all of the children at once. Okay, and this will go from left to right. So we can use like this like 2-pointer approach. So we could do let's just write a second method. So I'm going to say public Boolean verify row is equal to, or not equal to, it's going to take in a list of tree node like this, nodes, and then we're going to read it from left to right. So int start is equal to 0, int end is equal to nodes dot size, while start is less than end. While start is less than end. This is okay because we're dealing with a binary tree, so we don't have to deal with like odd numbers or anything like that. So, or that wouldn't even be an issue anyway. So so we're gonna say if nodes dot get start dot value, I think it's val or val, is not equal to nodes dot get of end dot val, then we just return false, and at the end we say return true, and then this is an infinite loop, so we need to say start plus plus and then end minus minus, like that. Okay, and so that's a for loop, and then we say verify row, or verify row, or is it verify level? Row of children. So if this is true, so if we say if not verify row of children, then so if that's not true, then we return false, and then otherwise we update the current level size is equal to children dot length. And I need to re-queue these values. This is weird, so this is going to be slow. So for tree node in children, and we just need to on queue them. So you say queue insert node like that. And then at the end of this while loop, we say return true if we're there. Let's see. Cannot find symbol Q. This is weird. Let's see what the Q interface. Insert. Is it add? Offer. Insert. Yeah, it's add. Yeah, did it here too. And I don't know where I got insert from. That's like maybe C++. And I have insert here too. Add verify row. Let's see. And children. Oh, wow. I have to define children outside of the loop. Jeez. I think I know how to write code. Wow. I legitimately don't know what I'm doing right now. Size. Ugh. Array index out of bounds. Oh, size. Wow, -1. Nice. And let's just do the other test case to verify that we're not doing this wrong. So if it's null, I guess I should just add it anyway. Is there like a range of values? So, you know why this is returning true is because when it gets to this level and it tries to compare, it treats this as if it's so I can't. How do I handle this edge case? I think the weird case is like I can't just say if the row size is not n+2 or in previous row times 2. Yeah, can't do that. But basically, I can't really add a sentinel value, can I? Because this could be anything. Let's think. So if this is null and null, this. I mean, I could just remove this null check. Like, and just say, just add them regardless. And then I have to do some weirdness here, right? If, so like, basically I just say if parent is not equal to null. Like that. X. And in this verify, so the verify method in this case is going to help me because so if I say if nodes dot get of start is equal to null, and so basically I need to verify that nodes dot get of start is equal to null and nodes dot get of end is equal, this is not the right solution. I mean, if I put so basically I'm pushing null and 3, null and 3. So when I look at it in the list, it's going to be null versus 3. So if this won't evaluate properly. If no, so basically it's nodes.get of start is equal to null, and nodes.get of end is not equal to null. So you can have like a bunch of OR conditions, honestly, like this. So I can chain them together. So if nodes.get of start is equal to null and is not equal to null, return false. Or nodes.get, so this needs to be the last condition checked, basically. And then we'll say, or nodes.get of start is not equal to null, and nodes.get of end is equal to null, like that. If all of these cases, if one of these cases is true, then we return false. Yeah. Let's see. Will this work? Ooh. Null pointer exception. Alright, where does it give me a null pointer exception? Oh. So basically, and then I need to, if nodes.get of start is equal to null and nodes.get of end is equal to null, then I just want to yeah, so if this is the case, else, if that's the case, then I'm going to say start plus plus and minus minus, and then else they're equal, and then yikes, this isn't the prettiest code that I've written by a long shot. Nice. And it's super slow. I wrote a previous answer here. What did I get? Oh no, that's my old one. Hold on, wait. This one. Okay, let's see. Whew! Look at that recursive solution. Super easy. Okay. Let's go back and do some more BFS, huh? So breadth first search. Here we go. Level order traversal. I actually had to implement this at work the other day, which is pretty cool. So we want to return a list of integers. So the trick here to make this run fast is that you need to kind of keep track of the number of children, so you're not polling and unpolling. So I think what you need to do is you need to say q integer, no, q tree node, q is a new linked list, like that, and then q if q, or if root the null, return new array list. Or you could do something like this, collections.empty list. Like that. And then q.add root, and okay, so while q not q that is empty, again, this is very straightforward. So while it's not empty, what do I want to do? I want to get the tree node. So I'm going to say, well, I have to get all the nodes in the same level. So if I say, all the nodes in the same level, I just wrote this. I can't really think about it right now. All right, so I say tree node parent is equal to, oh, right, because I have to keep track of int current level size is equal to 1. So while so I need to create a new list of the level while also queuing them up. So so for int I is equal to 0, I is less than current level size, and then I could say, well, first I gotta get this first level, list integer level is equal to new array list, like that, and we'll say level dot add, well, let's get the value, so q tree node current is equal to q dot pull, and we say level dot add tree node, nope, current dot val, and then we say if current dot left not equal to null, then we say q dot add current dot left, and Oops. And here I'm just going to copy this, place it here, and then right, and that looks good. And then at the end here, I need to say current level size is equal to level, shoot, will that work? Right, is equal to q dot size, like that. And then I need a return list up here. So list of integer is return list is a new array list, like that. And then I'm going to say return list dot add level, and then we just return return list, like that. Easy peasy. Current level, spelled it wrong. Dope. Nice. So it says it's slow, but does it ask you to do it recursively too? No. I feel like it'd be pretty hard to do recursively. But hold on. What were my submissions? None of them were good. So let's see what the discussion is. Java simple using Q. Traversal. Traversal that size. Yeah, I don't know. It's pretty straightforward, I guess. Alright, I'm kind of done with this, so I might try to do a little TypeScript. Let's see, TypeScript. I'm trying to learn this recently because I think JavaScript is worthless. How do you say install? Oh, nice. So let me try that. I love how I'm saying I'm doing it in React practice, but maybe, you know what? Make dir TypeScript practice. Alright, cd TypeScript clear ls. Okay, npm init. Alright. Yes, and npm install TypeScript. Alright, so let's look at the docs. TypeScript for a new programmer, TypeScript for a JS programmer, TypeScript for a Java programmer. Interesting. Alright, so it says TypeScript is a popular choice for programmers accustomed to other languages with static typing such as C# and Java. If you're familiar with JavaScript already, but are primarily C# or Java programmer, this introductory page can help explain rethinking the class. Might call mandatory OOP. Yep. The class is the basic unit of code and blah, blah, blah. In JavaScript, you can have free functions and data. Okay, that makes sense. OOP in TypeScript. That said, you can still use classes if you like. Some problems are well suited to being solved by traditional OOP hierarchy. We'll cover this later in the guide. Rethink types. TypeScript understanding of a type is actually quite different from C# or Java. Normal reified type system. Nominal reified type system. I think I read that wrong. C# or Java, any given value or object has one exact type, either null, primitive or known class type. We can call methods like value.getType or value.getClass to query the exact type at runtime. The definition of this type will reside in a class somewhere. Okay, these aspects are called reified nominal type system. The types we wrote in the code are present at runtime, and the types are related via their declaration, not their structures. Types as sets. Okay. Once you start thinking of types as sets, a set of values that share something in common. Because types are just sets, a particular value can belong to many sets at the same time. Oh god, what did I get myself into? Okay, once you start thinking of types as sets, certain operations become very natural. For example, in C#, it's awkward to pass around a value like that is either a string or int because there isn't a single type that represents a sort of value. In TypeScript, this becomes natural once you realize that every type is just a set. How do you describe a value as a string or number? Simply belong to the union of a string or a number. Wow, okay, that's pretty cool. Interesting. Identical types? Wait, what? Alright, let's see what this looks like. Let's just follow the tutorial a little bit. Let's go to docs. Handbook. Do they have dark mode on this site? Alright, basic types. Alright, let's see. We close this, and I want to say code here. Alright, so let's just get started. Basic types.ts. Alright, so let me just snap this to the side. Alright, so Boolean types. I can minimize this, right? Yeah, okay. So let's write a comment, Boolean types. Alright, so let is done is a type of Boolean. False. Okay, so this looks a lot like Scala. If anybody's ever seen Scala, so let's say Scala. I don't want to download it, but let's just look at the docs. API docs. So in Scala, let's see. There's a Scala book or something. Two types of variables. Learn tour of Scala. Here we go. Unified types or basics. Let's go to basics. Alright, yeah, so you don't have to give an explicit type, but like this is exactly like Scala, which is cool. Anyway, so I'm pretty sure I can just almost exactly write Scala code, but in TypeScript. Anyway, okay, so that's a Boolean. So it looks like there are numbers and big int. So there's no like float or double or whatever in JavaScript. It's just a number, which is very interesting. So let's see, and then there's a string. All right, string array. Interesting. TypeScript, like JavaScript, allows you to work with arrays of values. Arrays can be written in one of two ways. In the first, you use the type of elements followed by square brackets. This is very similar to Java. Or you could do it like this, which is also very similar to Java. So like let list is equal to array of that's Scala number like that is equal to array. of number. Can you do that? Yeah, cool. Very cool. All right, and then there's tuples like that. It's weird. Every language has this kind of stuff, which is a little weird because like a tuple in Scala looks like this, right? Like a tuple, let tuple is like, you know, 1 and then hello. And I think it's similar in Python too, but here we are learning something brand new in JavaScript. But it has to follow the type. Oh, that's very cool. So if I say like let my weird tuple, I just can't spell, of string number, I can't just say my weird tuple is equal to 10 hello. Oh, very cool. Nice. Okay. Easy peasy. Enums. This is all very straightforward. Declare const. What is this? Wait, there's an unknown type. God, what the hell is this? Okay. Declare const. Maybe could be a string, object, Boolean, undefined. Oh my. Any. Okay. Void type, so you don't want to return anything. Null and undefined. Never. Never is a type. It represents the type of values that never occur. For instance, never is the return type of function expression or an arrow function expression that always throws an exception, or one that never returns. Weird. Object can be an object. Type assertions. Okay, so this is like typecasting here. So I can convert a value to a string and then get the length of that string. Note about let. You may notice so far we've been using let instead of the keyword var, which you might be more familiar with. The let keyword is actually newer JavaScript construct. Typescript makes available. You can read the handbook about how let and const fix a lot of the problems with var. Cool. All right, so let's go a little bit faster. All right, so interfaces. So interfaces are pretty straightforward because it's a very standard thing to do in Java and Scala. In Scala, they're called traits. So if you look at a trait, you're basically defining some functionality that you expect to be there. So in this case, a trait of iterator accepts a type A and defines the template of functions that it expects to be implemented. So for example, this iterator class is going to have a function that needs to be implemented called hasNext that returns Boolean, and then a function called next that returns the value of type A. So that's pretty straightforward, but the only other weird thing about this is you can have like multiple inheritance with this, or which is actually kind of cool. But anyway, so let's jump back to TypeScript. All right, so at our first interface, the easiest way to see how interfaces work is to start with a simple example. Okay, so function print label, and the label object is an object that takes a label of type string. Okay, my object size 10, label, and weird, what? So it's saying function print label, labeled what in the world? Label. I see. So string. All right. So I think this is weird to me because what you're basically saying is you're defining what would be equivalent to an inline class in Java as an interface. So you're basically saying that this print label function is going to take in an object that has a field or a property called label of type string, right? Otherwise, you could also declare a type called label object. Let's just make it capital like that, and you could say the type is a label of type string like this, and then instead of here, what you could do is you could say label object. Yeah, interesting. So now I can say console.log of labeled object dot label. Okay. So this syntax is a little weird. Like, I wouldn't necessarily start with this because unless you kind of know what this is actually doing, then it doesn't really make sense. But the power of this is, like, I can also define another property. I can say like as a function. So, and then the type here is going to take in an int, or let's say a value, and then it's going to be a number that returns a string, right? So now the label object also has, so I can say console.log of label object dot func of 10. Isn't that cool? So basically, what this is going to happen, what's going to happen is the label object. So when I define a label object, so if I say something like let my object of type label object equals, and I say label print, and then my func is actually is going to take in a value number, so say val u, and then what it's going to say is just going to return plus. Actually, I can just do something like backticks of value like that. I think. Does that not work? Interesting. So now if I were to just call function, or if I were to call print label of my object, it should compile. Now the only weird thing is, like, how do I run this? I've never actually run JavaScript from the command line like this. I don't know. I assume it'll be right, but it should just print out 10. All right, cool. So yeah, so I did something like this. I skipped ahead because there's like a literal types here, but the interface you can define like that. Okay, what else? Optional properties. Oh, this is cool. Not all properties of an interface may be required. Some exist under certain conditions or may not be there at all. The optional properties are popular when creating patterns like option bags, where you pass an object to a function that only has a couple of properties filled in. But then you have to do like all this if condition unwrapping stuff. Can I do that in a type though? Turns out I can. But no, I can't do that. So basically I have to check to see if label is there first before I use it. Okay, so that's not a big deal. Read-only properties. Read-only array. Read-only versus const. The easiest way to remember whether to use read-only or const is to ask whether you're using a value, variable, or property. Variables use const, whereas properties read-only. Okay. Excess property checks, function types. Yeah. Oh, very cool. So I could do this. So interface func. so the type of it is a function that takes in source, string, substring, and takes in a string, and then returns a Boolean. So this syntax isn't actually an arrow. Weird. Can't do that. I see. So it has to do this. Cool. All right. So that's pretty straightforward. Again, so if you're thinking about what this looks like in Scala, it would look like this. This is the exact same thing. But I'm just saying, like, okay, so if I wanted to define this iterator interface or this iterator trait in TypeScript, it would look like this. So it's a interface iterator. And I think they do like type generics too. Yeah. So iterator of type, and then you say some function that returns Boolean, and then another function that returns t. So this is the equivalent of saying has next, and then this is the equivalent of saying next. Very weird though. Why? Like, it's weird that I can leave this unnamed. Can I just say like function has next, something like that, or has next? Okay, so I can name it like that. I can say next like this. Very cool. All right. So I hope while you guys are watching this, you're realizing like once you know one language, it's kind of all the same. You're just kind of translating between the two, or any N languages. All right, so search func. Okay. Wait. My search is a function. Oh, this is just a function call. Okay. Indexable types. What does that mean? Similarly to how we can use interfaces to describe function types, we can describe types we can index into. Ah, I see. I see. Oh, weird. Wait, what? Index is a number that returns a string. Okay, so I'm initializing it, and then so I initialize a tuple, and then I get at the first index. Weird. Very cool. Interface animal, dog extends animal. Okay, so you can do inheritance on interfaces, which makes sense. Number dictionary. Okay. So I want to make sure you guys understand why this is important. Interfaces are very important because you can pass around the template of what the functionality is that you expect. So for example, if you wanted to say you have multiple types of dogs, right? But you don't want to just say, you don't want to call a function. Say you have a function that says print out the dog breed, right? But you don't want to write a function that says print out, like you don't want to do something like this, right? So if I take this code here, I just put it in here. Oops, I just say paste. All right, so what you don't want to have, so say I have two breeds. So I say I have, I don't even know dog breeds. So I say class golden retriever. Retriever extends dog. Can I do that? Implements dog. Wait, what? Right. So now it's telling me because I need to actually implement the interface, but that's fine. So now I can say breed golden retriever And I can say name is Sally. And then say I have another dog called what's another dog? I'm not a dog person, so I don't really know dogs. But poodle, right? So now let's say poodle and Sadie or something, right? So very dog name. All right. So now what I want to say is, say I write a function called print function print breed, and then say it only takes in a poodle. Poodle, and the type is poodle, right? That's a poodle console.log poodle.breed, right? So this works fine, right? But the problem is, so say I wanted to print the golden retriever's breed, right? So instead, what I would have to do is I would have to say, like if I say print breed on, say, new golden retriever, like that, it won't work because when I hover over, golden retriever is not assignable parameter to type poodle because this function is expecting a poodle, right? But what you do instead of writing an individual function for poodle and golden retriever is you say dog, like this. So now you can just say dog, that breed, and now I can say print breed of poodle, like that, and I can say print breed of new dog, like that. Oh, not dom string list, I can say dog, like that. And both work, or should work. Oh, new golden retriever, right? Okay, so that's what that will look like. Okay, so that's why you use interfaces as opposed to, you define the methods and fields that you want to have in an interface, and then you provide an implementation of that interface, and then the functions that you use to call on those interfaces takes in the interface and not the actual implementation. That's important. Okay? All right, so that's why interfaces are very nice. You can also describe methods. All right, so yeah, so basically it looks like you can have default functions, which is fine. All right. Extending interfaces, hybrid types. Cool. All right. So let's see functions. Functions are pretty straightforward. Anonymous function, named function, matter, typing functions. Yeah, so you just have to tell it what type you're getting. So the function syntax is the same no matter where you are. So let's look at Scala real quick so I can give you guys an example. I think higher order functions. See what that looks like. Yeah, so in Scala, you know, x takes in an int and you square it, or double salary, right? Cool. And the cool thing is you can take a salaries and map it, and you just pass in a function. And I believe you can do this in JavaScript or TypeScript as well. So let's say I have a function. So let's say I have a list of numbers, right? So let numbers to array of number. Let's say new array. So numbers dot push. All right, you know what? Let's make our lives easy. So I can say let numbers equal an array of number is equal to 10, 20, 30, and then let mapping function equal to, right? And I can do, so I'm going to take in a value of type number, and then I'm just going to return that value times 2, right? And then I can say let new numbers, let's say double numbers, is equal to numbers dot map, and then you just pass in a function, mapping function. Like that. Cool. So that's a benefit of functional programming, is that you can just define a function, a stateless function, or whatever, and then you just pass it into a mapper or a reducer, like any of the functions that you can perform on an array, and it will just return values that it will execute this function on every value in this array. So that's nice. All right, so it's saying my add is a type of function that takes in two numbers and returns a number, and then you define the function, the parameters, and the number. Okay, yeah, that's good. Inferring types, type inference is always really nice. You don't need to say what type my add is. And yeah, so I'm using some type inference here. So like, I think I can do this, and it's still going to compile, right? Optional and default parameters. See, optionals are, you have to do something like that in Java, but okay. This, ooh. Yo, wait, what? So the weird thing with JavaScript is like, nobody really knows what this is referring to, right? So let's say, look at an example, or let's actually read the description. In JavaScript, this is a variable that's set when a function is called. This makes it very powerful and flexible feature, but it comes at a cost of always having to know about the context that a function is executing in. This is notoriously confusing, especially when returning a function or passing a function as an argument. Look at this example. So letDeck is just an object, right? Suits, cards, and then create card picker, which is a function. What? Is a function that returns a function? Who on earth would write code like this? So look at that. Look at that method signature. Create card picker. It's a function that returns a function that returns an object of suit and a card number. So this dot suits is referring to this. Oh my god. Oh my gosh. Let's see what else do they have to say. Notice that create card picker is a function that itself returns a function. If we tried to run the example, we would get an error instead of expected alert boxes, because this being used in the function created by card. Oh, so it is scoped. So this is fine. So you could do something like this dot picked card or this dot picked suit, but you couldn't do. Yeah, it's all okay. So that makes sense. That's more of what I expected, but yeah. Okay. So it's all about the scope in which it's called. So this is always referring to what's in the scope, I think. Okay, so we can fix this fix this, get it? Fix this by making sure a function is bound to the correct this before we return the function that's used later. How the heck do they do that? Oh, see, that's interesting. So by making an arrow function, it exposes this to the deck context. Weird. All right. You can overload functions. Okay. Man, literally, when you learn one programming language, they all are like the same. Boolean types. Okay. Classes. Classes are cool. Inheritance extends animal. We talked about this with interfaces. So, I don't know if this is true in JavaScript, but you can't extend multiple classes, but you can implement multiple interfaces. So that's the benefit too. Is like you can have a poodle that also implements like a bark interface, or like say interface. Let's define it up here. So like if I have an interface called bark, and I say like make sound, so function is something that returns a string, right? So now what I can do is not all animals bark, so what I can do is I can say implements, oh no, extends, wait. I should be able to do this. Or can I also say implements bark? Maybe it's a comma. Yeah. Weird. So now I have to say bark or make sound. And then you just say whoop. Interesting. So that's how you do multiple of that, but can I also do, let's say, I don't think I can. I'm just gonna like guess and think say that I can't. Let's see, classes. All right, cool. So I'm pretty sure I could probably pick up React or pick up TypeScript without a problem. Yeah, so type generics. So generics are really useful for being able to write like one function that like handles all your cases. So as an example, if I wanted to write an add function, well, it doesn't really apply here, but let's say I wanted to write an add function. Then I could say function add, and it takes the type like this, and then arg1 of type t, and arg2 type t, and returns t, like that. So I say return arg1 plus arg2. Oh, yeah, these just have to be numbers, but I think you can do like extends number, like that. And then extends up. Interesting. Can't do that. Is it? Can I say it here? Well, I think I can. Nope. Doesn't work, but why is it saying this? Yeah, no. Well, that screwed up my example. But you can do stuff like this in other languages, so it's weird that I can't. Number is not assignable to type T. Number is assignable to the constraint of type T, but T could be instantiated with a different subtype of constraint number. Yeah, it's basically saying, look, you're giving it a type T that extends a number, but T could also be instantiated as something else. So JavaScript typically lets you do whatever the hell you want, but this is kind of a breaking thing. Identity my string. Okay. Generic types. Generic classes, very cool. Generic constraints, yeah. All right, cool. So now the next thing I'm going to take a look at is like React with TypeScript. So TypeScript supports JSX and correctly modeled patterns, code bases like use state. Getting set up with React, create React documentation. React TypeScript cheat sheets. Introduction. Prerequisites, a good understanding of React. Yikes. Yeah, I'm just learning. Actually, yeah, I'll just respond to you. Yeah, I'm just learning TypeScript. It doesn't seem too hard, just because I have a background in Scala and Java, so they're just normally statically typed, which is pretty cool. But I've been trying to. The point of me learning it is basically to figure out like to make my React code better. Because I'm basically just passing around random objects and have no idea what's actually going on. But if I can get stuff to compile properly and kind of get some guarantees of like what sort of information I'm dealing with, then that kind of helps. Code sandbox. I don't want to look at this. Like I just want, give me. Oh my god. Okay. So const with sample higher order component is a P that extends object. So P. Oh man. All right. So let's try to read this. So props are equal. Component. Props P. Wow. Is this really what React looks like with TypeScript? This can't be real, right? Let's see, migrating. Let's look. Oh, it looks like a lot of companies have done it. I just want to look at somebody's code who wrote some React components in. Adding TypeScript. Create React app.dev. Here we go. Here's an example. And let me just make this a little bit bigger so you guys aren't going blind. Whoops, it's too big. All right, so type faux act function component props context. Wow. All right, so let me actually read this. React is a popular library. Typescript. To understand how TypeScript works with React components, you may want a primer on generics, whatever. Okay. First, we'll look at how generic interfaces are used to map React components. This is a faux React functional component. Okay. So all this is saying is this is a fake component that takes props, which extends an object. So yeah, your properties that you get passed in a component is just an object. So it's basically saying there's an object props that extends component. And then what you're also passed in is a props object here, the types. And then you're also passed in a context of type any. So like if you're passing in like a Firebase context or a context that you create, then this is where that comes from. And then this also returns a faux component or null or a JSX element. Interesting. So let's see if my assumption was right, because now let me actually read what this is actually doing. So faux act component. This is a horrible name. Not hating on whoever wrote the docs, but it's pretty bad. All right, so is a generic function which relies on another type, props. Okay, yep. Props has to be an object to make sure you don't pass a primitive. Okay, and the props type will be reused as the first argument in the function. Yes. So when you define a React component, like you say const my component equals props, and then like this, is basically all this is basically saying is that's exactly what this method is. So if I were to say this is JSX, it's just going to be props like that, and this won't compile because it's, you know, I haven't installed React, but that's basically what this would basically do, assuming that props is a type here. Cool. All right, so then they define an interface. So interface date props. So you have a date and a message. All right. We can create a component, a date component, which uses date props interface. Oh, that's really convenient. That's really convenient. Although, doesn't React already support prop types? But I guess this is a little bit more stringent, and it just allows for compatibility with like React with TypeScript. I mean, I don't know what I'm saying. It's late. All right, so const date component, faux act component, date props. Then you have a time component, date time. Cool. Easy peasy. Okay, so now let's take a look. This looks like a little bit more of a complicated example. The other component API is a class-based one. Here is a simplified version of that API. Okay, so you have a class component that takes in props and state here. Then you have a set state function that takes in a previous state and props, and then returns props, a callback, and then a render function that returns a flow class component or no. It's just this is very straightforward actually. Okay, so now the React library comes with its own type definitions, like these, but are much more comprehensive. Let's bring those into our playground and explore a few different components. All right, so export interface props. The user's name is a type string, and the priority is an optional parameter. Type Boolean. Const print name React FC. What's React FC? Functional component? Yeah, looks like it. Takes in props, which we define here, props, and then props.priority, font weight bold or normal, and then props.name. Interesting. Okay. Show user, print name Ned. Dope. This is really cool. it's going to take a minute for me to realize, like, for me to pull in these, like, understand the React API for TypeScript. But this is very straightforward because you can define, wait, hold on. Wait, this is weird. Hold on, wait, am I missing something? Is this the same props as this? I see. Okay. And then using functional components, counterexample. TypeScript works with modern React too. Here you can see that the count and set count have correctly been inferred to use numbers based on the initial value passed in the use state. Interesting. So import use state, use effect from React. Okay, that makes sense. Okay. So it's just using type inference, is that it? But I would actually like to know. Oh, cool. So React dispatch. Oh, very cool. Very cool. Awesome. All right, so I'm going to integrate this into a React project at some point, and this should be pretty straightforward. But you know, if you guys want to see me build something specific, let me know. The reason why I haven't made any videos recently is, like, I'm fresh out of ideas. But if you enjoyed the stream, I'd definitely do this again. Yeah, it's late on a Friday, and I'm gonna go enjoy my weekend. But I really appreciate you guys tuning in, those of you who did. And until next time.